Hey guys, so I'm going to take you through the work lesson now, the at-home mini investigation. So what you're going to need for this lesson is a tiny car or a ball and something that object can run into, something heavy and strong. Okay, so for the first part of the lesson, we're going to put energy into the system and take energy away from the system. So this is us doing some work on an object. So let's begin. Okay, so the first part of the lesson is discussing work. So last lesson we saw that if energy flows into a system or out of a system, that energy is called work. So our system is going to be our little car. Okay, this car was, I think Janelle got this car in Peru when she was there, but it's super cute and it rolls well. Okay, in our situation, we're going to ignore friction, even though we know it's a realistic quantity. Fun fact, friction will always do negative work on a system because it's always opposing the direction of motion. More on that later. Okay, so our first situation is we're going to place the object on a smooth, level surface. We want some energy to flow from your hand into the system, from your hand into the cart. Describe how you can do this. Well, if I wanted to give this car some energy, basically I would push it, right? I would push it and I would get it to move. Great. Okay, so that's all you have to describe there. So we have to draw a motion diagram, a force diagram, and an energy flow diagram for this. Basically, we're just looking at the time in which I'm pushing it. Okay, so I'm applying a force in whichever direction you want. I think in my answers I pushed it to the right. Okay, so I drew my force diagram to the right. No friction there. And in order for energy to flow from my hand to the cart, I have to impart energy onto the cart. So I draw an energy flow diagram. My hand is the environment because the car is our system, and I'm giving energy to the cart. Okay, so what I've said underneath all of these is the hand giveth. That is, the hand giveth energy to the car. Okay, and your car is accelerating, so your motion diagram looks like that. Yeah. Okay, in the second scenario, my car is already moving, and it says it's initially moving quickly. We want the energy to flow from the object to your hand. Okay, so let's get that car going, and we apply a force to it to stop it, right? Oops. Oh, I gotta love at-home videos, right? Okay. So the car is moving originally, and you apply a force. The car gives your hand the energy now. So we're going to draw a force diagram again. So in that case, if the car is moving originally, ignore my hand right now, the car is moving originally, I then apply a force to the car, okay? It's going to be opposite the direction of motion. Okay, so what I've said here in my force diagram, that motion, say it was that way, I'm applying the force the other way. Okay, so that's important, is to see the difference between the direction of motion and the applied force. In this case, the hand taketh away. The hand takes the energy away from the car. We draw the arrow from the car to the hand. Okay. So basically what's happening here is in scenario 1, I have put energy into the system by applying a force on the car in the first scenario. Okay, so applying a force, giving the car energy. In the second scenario, the car is coming towards me. I take the energy away by applying a force in the opposite direction. Okay, so that is work done. So the important thing to note here is that work can be positive or negative. Okay, depending on what you're doing. If you're trying to take away kinetic energy, then it's going to be negative. And if you're trying to give kinetic energy to the system, then it's going to be positive. Okay. The sign of the energy, positive or negative, is just tells you whether or not you're gaining or losing energy. Okay. right, so you'll work through number 4 and 5 on your own. And then for the part B, this lesson sort of goes through what happens if you know this mathematical expression for work. Okay, work is the force applied, or whatever force you're talking about, times the displacement. So these two symbols are just magnitudes. Theta, cosine theta, is the angle between the force and the displacement. So your force is going to be pointing one way. Your direction of motion, your displacement, is going to be one way. And the angle between them, that's the theta we're looking at here. Okay, so just to clarify, if I push something this way, my applied force is that way. The displacement that the object traveled is also that way. So that means the angle between them, since they're both in that direction, the angle between them is 0. Okay? If the object is moving, say, this way, and then it hits something here, and that, of course, applies a force opposite to it, then the angle between the displacement, so during the force, it goes to the left, and the force being applied by the box of pennies is to the right. The angle between those two things is 180 degrees. So that's what that angle means, okay? So you're going to notice that in order to get positive work, the force and the displacement have to be in the same direction. And in order to get negative work, your force and your displacement have to be in opposite direction. And you're also going to discover in the homework that if you, for example, if you're moving something to the right or left, if you're asking about the work done by the normal force or by the gravitational force, since those two forces are perpendicular, cosine of perpendicular, which is 90 degrees, is going to be 0. Okay, so you're going to look at the conditions of work for different situations. So that's using the work, force, displacement, cosine theta equation. Note that the units for work can be either in Newton meters or in joules. And then you'll do some calculations with that. So please refer to my solutions here if you want to. This is just to clarify sort of and explain sort of what the lesson was all about. Finally, the last part of the lesson is about network. Okay, that is not to be confused with network as if like your Wi-Fi network goes down or whatever it is. Network is kind of like your net force. So you can have, in this example here, you're pushing on the cart and the block pushes on the cart as well. So lots of things going on, lots of forces acting on an object, and lots of energy transfers happening. But ultimately you can figure out like the total energy of the system, because some energy is going in, some energy is coming out, and if you calculated the work done by each force individually and then added them together, you get the overall work done, or the overall energy given or taken away from the system. Okay, so I hope that makes sense. Please make sure you refer to my solutions as much as you need to. Refer to these videos if they helped. I don't know. Please let me know. What I've been seeing lately is that not too many views on these videos, but you have been saying that they've been helpful, so please comment if you enjoy them, or if they're helpful, or if I can improve in any way. I know I went through these quickly, but this is just an overview. If you need further assistance with this stuff, please make sure you email me, and we can go over more things in detail. Okay, it is meant to be an investigation, so I'm hoping that you did try this on your own or with a partner. Yeah, look for my answers to the homework, and good luck to you. Okay, take care.